Hello, physics students. I am Mr. Williams, and today we're going to talk about potential energy. And you should be able to give examples of potential energy, calculate the gravitational potential energy. So let's look at these three bears, the wee bear bears. Which bear has the greatest potential to fall and get hurt due to distance from the ground? Did you say brown bear? Good. Let's talk about some vocabulary. Potential energy. Potential energy is the energy stored in an object due to its position. Position relative to what? It could be a lot of things. One form of potential energy is elastic potential energy. Elastic potential energy is the energy stored in an object as it is compressed or stretched. Look at this guy bouncing on the trampoline with a skateboard strapped to his feet. Another example of potential energy is chemical potential energy. Chemical potential energy is the energy stored in the chemical bonds. The next form of potential energy is the potential energy of gravity. So gravitational potential energy, the energy stored by objects due to their position above the Earth's surface. Wow, look at that picture. Do you think that's real or photoshopped? Objects that are not in motion still have energy. The energy is stored in the object. Because of this, the object has the potential to cause change. For example, as an apple falls from a tree, the hanging apple has energy due to its position above the earth. Stored energy due to position is called potential energy. And as you see this feather float on down, when it's up high, it has potential energy, and it floats on down to the ground, converting that potential energy into kinetic energy. And then as it hits the ground and is standing still, it has no more potential energy. As it's standing still, it doesn't have any more gravitational potential energy specifically. It also doesn't have kinetic energy. I wonder where that energy went to. Hmm. All right, this next one, this is the reason why we don't let students have rubber bands in the classroom. Elastic potential energy. Elastic potential energy is the energy that is stored in a material that can be stretched or compressed. So examples of elastic potential energy are a stretched rubber band, a bouncing ball, a compacted spring, anything that can stretch or compress and then go back to its original shape, that would be containing elastic potential energy. Chemical potential energy, one of my favorites, is energy that is stored in the bonds between atoms or molecules, and that would be called chemical potential energy. Your body releases the energy stored in pizza to give you energy to go about your day. If you don't eat food, you won't have very much energy. Gasoline holds chemical potential energy that is violently released when it's ignited. Gasoline can be converted into very useful forms of energy, such as putting into a car and transporting that car from one side of the city to the other side of the city. You can see another form of chemical potential energy in the firecracker animated GIF. It was gunpowder, and that energy is very obviously being converted into another form. The next type of energy, which we'll spend the most time on, is gravitational potential energy. Anything that can fall has gravitational potential energy. The energy is stored inside of the object due to its position above the Earth's surface. Gravitational potential energy depends on the mass of the object and the height above the ground or whatever surface that it could potentially fall to. See, this cat had some cute, cuddly gravitational potential energy before it fell. And these kiddos, they discover that the young kid jumping off of the porch, it had some gravitational potential energy. Adorable. So how can we calculate gravitational potential energy? So we're going to use the gravitational potential energy equation. GPE is often used for the gravitational potential energy abbreviation. Sometimes you could see E with the subscript K, or E with the subscript G rather. We're going to use GPE. So GPE stands for the gravitational potential energy, and it's measured in joules or abbreviated with capital J. That will be on your quiz. Remember that. M stands for the mass of the object, and it is going to be represented by, and it will be measured in kilograms and represented by the abbreviation kg, also on your quiz. G, lowercase g, case is important. G is the acceleration due to gravity, and that's going to be 9.8 meters per second squared. So the 9.8 is the acceleration due to gravity on the Earth. If you go to the moon, you are going to accelerate much less because gravity is much weaker. If you go to Jupiter, the gravity is much stronger, and so it would have a much greater acceleration due to gravity. Please note, when you see meters per second squared, that is a very unusual unit. It's really hard to think of a squared second. We can think of a square meter, like 1 meter by 1 meter would be like a square. Second squared, we get this because acceleration is the meters per second with that speed, would be how much is your speed changing per second. So if you increase 10 meters per second each second, so for every second you go 10 meters per second, 20 meters per second, 30 meters per second, so on and so forth, you'd be increasing that 10 meters per second each second. So we call that meters per second squared. Do not square 9.8 in the equation. Meters per second squared is a unit, a very unusual unit, but you don't square that unit mathematically. So once again, G is the acceleration due to gravity, 9.8 meters per second squared. H stands for the height from the ground or whatever surface you are could potentially fall to. And we measure that in meters, and that is going to be abbreviated M. Let's do an example. A book with a mass of 2 kilograms falls off a desk that is 1 meter tall. How much gravitational potential energy did it have on the desk? Okay, first we're going to start with the equation. Our GPE equals mgh. Now, we are always going to be using G equals 9.8 meters per second if we're on the Earth. And so that's something that you should remember. If we are on some other planet or moon, and we'll give you that what the G would be if we were on a different gravitational field. Okay, next, let's set up our knowns and unknowns. Let's figure out what does GPE equal, what does mass equal, what does G equal, what does H equal. All right, so our mass. What was the mass of the book? Well, it tells us, okay, and it's color coded, and so we're going to use 2 kilograms for the mass. Okay, next, G, what we're going to use for G in that equation? Well, we told you G equals 9.8 meters per second squared because that is the acceleration due to gravity on Earth, right? So we're going to put that in there. And next, what's the height? Well, we said the desk was 1 meter tall, so the book is going to fall 1 meter. Okay, so we're just going to rewrite that gravitational potential energy equation. Are you following along? You should write this down. GPE equals m times g times h. So we're just going to start substituting in the numbers for each of those variables. Well, for mass, we're going to enter 2. Okay. For our g, our gravitational acceleration, we're going to enter 9.8. And for our height, we're going to enter 1. And next, we're going to grab our handy dandy calculator, and we are going to multiply 2 times 9.8 times 1, and you will end up with 19.6 joules. So we now know how to calculate how much energy and gravitational potential energy an object has when it is off the ground.